Hello, and you found your way back, which is awesome. Hopefully, you enjoyed the last series. In this series, we're actually going to be conducting denial of service attacks. As always, all of the lab scenarios I'm going to show you today are offered by the CEH iLabs version 11 in practice for the CEH practical exam. Now, I am not sponsored by CEH, and I really am not trying to make any money off of any of this. I would just like to bring these tools and these scenarios and the practices to a wider audience. Now, a little bit of my background. I am a cybersecurity and ITIM's past student, as well as a instructor that was lucky enough to be able to teach students how to execute some labs in a local college of mine. Now, before we get into this, it's pretty important that we do understand what a denial of service attack is. So, in a denial of service attack, basically, we're trying to use the most amount of resources as possible to our victim's machine, thus, hopefully, leaving it unusable. So, DoS and DDoS, which is a distributed denial of service attack, they've both become increasingly popular. This could be attributed to how easy they are to perform or how simplistic the plans are to actually carry out. A lot of these attacks that we're doing today can kind of be put into the realm of what's known as a script kiddie, which is basically an attacker who is using pre-established tools and honestly the littlest amount of brain work required to execute. So, some of these actual attacks we're going to be working on. We're going to perform a DoS attack using SYN flooding through Metasploit. We are going to use hping3, which lets us basically craft our own packet, and we will use both high and low orbit ion cannon. Now again, let's kind of do an overview of a DDoS and DoS attack. Mainly, we are attacking the network bandwidth. We're trying to exhaust this network, the application, the service resources, and thereby restrict legitimate users from accessing their system or network resources. In general, there are a few attack vectors when it comes to DoS and DDoS, and that would be a volumetric attack, which is where we're actually using UDP, ICMP, flooding, the ping of death, Smurf attacks, pulse wave, zero-day attacks. There's also protocol attacks in which we're consuming resources like connection state tables present in the network infrastructure and components such as load balancer, firewalls, and application servers. Those attack techniques kind of range from SYN flooding, sending fragmented packets, spoofed session flood attacks, ACK attacks. There are application layer attacks in which we consume application resources, thereby making them unavailable to the legitimate users. In these, we can use HTTP GET/POST attacks. We can use slow LoRa's. We can use UDP application layer flood attacks. Basically, anything we're doing right now is just to target another machine and exhaust its resources. Now, in the last lab, I was pretty upfront about you don't want to run any of these against your own computer. You want to run it in a sandboxed environment. However, with what we're about to do, none of it is too ridiculous. If you have another PC in your network and you wanted to target it and maybe run a few of these against it, you at worst are just going to have to restart your computer. So with all of that said, let's go ahead and perform our first task, which is going to be to perform a DoS attack through SYN flooding using Metasploit. Now, SYN flooding takes advantage of a flaw with regard to how most hosts implement the TCP three-way handshake. This attack occurs when the intruder sends unlimited SYN packets or requests to the host system. The process of transmitting such packets is faster than the system can handle. Normally, the connection establishes with the TCP three-way handshake, and the host keeps track of the partially open connections while waiting in a listening queue for response, acknowledgement packets, or ACK packets. Now, Metasploit is a penetration testing platform that allows a user to find, exploit, and validate vulnerabilities. Also, it provides the infrastructure, content, and tools to conduct penetration tests and comprehensive security auditing. The Metasploit framework has numerous auxiliary module scripts that can be used to perform these denial of service attacks. So one of the first things we're going to do is I'm actually going to navigate to my Parrot OS. Now I must warn you, Parrot runs a little slow in this environment. So if you see me creeping with the mouse, it's just because I don't want it to do anything crazy. So after we load my Parrot, the first thing we're going to do is, of course, just open up a terminal. Now up here, Parrot actually uses what's known as the MAT terminal. So we'll go ahead and switch to it. And now to conduct these attacks, one, you could just add whatever user you're using to the wheel group or anything with sudo permissions. But what I'm going to do is I'm just going to go ahead and switch user. And I'm going to use root. I'm going to cd into my basically home directory. And I'm going to clear the screen. So after doing all of that, and saying no to the updates, all we really have to do is determine whether port 21, which is FTP, is open on the victim's machine. So to do that, we'll just nmap-p. We'll enter the target port. Let me move this mic real quick. Might be loud, sorry. Can't really get to my keyboard. And after that, we will enter in our target's address, which in this case is pretty easy, just all 10s. And we will see that FTP is in fact open. This is not common practice in today's infrastructure. I would highly recommend using port 22 as far as secure shell. You can also use port 22 for secure or shell file transfer protocol. And you can also use FTPS over ports 989 and 990. But now that we know it's open, basically all we have to do is start sending send packets. To do that, we'll open up our Metasploit framework console. And we should get a pretty nice graphic. Let's scroll up and look at that. You always got to appreciate how much work they actually put into Metasploit. So after that, there are a good bit of commands that we actually have to enter. First, we're actually going to say use, and we're going to specify, oh, well, help if I typed, right? Use auxiliary, DoS, TCP, send flood. Go ahead and press enter, and you'll notice down here we're actually inside of this module now. So from here, the next step we need to do is we actually need to configure our options. To do that is pretty simple. First, let's look at what's available with the show options command. And you'll see here required and current setting. Now when we see stuff like this, we'll go over it as well. You can also just read the description over here, but we will go over it as we enter in our options. So, first thing that we're going to enter is we are actually going to spoof the IP address, excuse me, of the parent machine. To do this, we're just going to set a few options. The spoofing option is shost, but to do this, we actually have to specify our target. We're going to specify our port. And now we're going to set our spoofable address. And in this lab environment, my .19 is actually a Windows Server 2019 machine. So we are actually going to be sending this traffic from a spoofed address. So now if we go to show options, we should see under the current settings that we have actually put in all of the needed information. Now, the number of bytes to capture, we're just going to leave it at the default, which is 65,535. After we do this, pretty simply, we actually just type in exploit with an L, exploit. So I'll let that run for a second. It actually should not take that long. Now what we're going to do is we'll go ahead and navigate back to our Windows 10 machine. Now at this current setting, we actually should be able to still conduct normal use. So we'll look at the performance. And as you notice, the CPU is peaking up and down a little bit, but overall, it's not doing anything crazy. Right now we're using about 15 to 18% of the CPU. So of course, if this type of attack was happening in your network, you could still use the PC. It just might slow down when you start opening up browsers or try to perform your daily operation tasks. Now, what we can do is we can actually open Wireshark to show this traffic a little bit more. And you'll notice that we do have a little bit of spiking going on. So we'll set this to the Ethernet. And if you notice, we have a lot of 10.10.10.19 packets. And if we were to open these up, you will see that they are all SYN packets, with the exception of a few SYN-ACK and a lot of resets, which is just because the traffic is just piling in. Now, if you'll also notice, the port that is associated with this type of traffic is 21, the port that we associated our Metasploitable framework with. So let's open back up our task manager and let's see how far we've grown. So now we're seeing a lot more spiking. For a second there, it was at about 66%. That's just going to come down to the fact that we are running Wireshark, which is a bit noisy on this computer. But again, this is not something in itself, being a one system attack or a DoS attack, that is going to take down this network. So letting it run, letting it see how much it builds. In the end, about 30% of the CPU is being used. So nothing extreme. So we're going to go back to Parrot. We're going to Control-C it. And we're going to stop the execution of the attack. Now if you notice up here, we were actually using a good bit of our own processes to actually execute this attack, which is why normally you're going to use a botnet, which is just a collection of computers under your control that respond to what's known as a CNC, or a command and control center, and that is how you would execute a distributed denial of service attack. But with that, that's basically how to perform a simplistic SYN attack using MSF. So next, let's actually talk about using hping-3. Now, hping-3 is a command line oriented network scanning and packet crafting tool for the TCP/IP protocol that sends ICMP echo requests and supports TCP, UDP, ICMP, and raw IP protocols. It performs network security auditing, firewall testing, manual path MTU discovery, advanced traceroute, remote OS fingerprinting, remote uptime guessing, TCP/IP stacks auditing, and other functions. Here we will use the hping-3 tool to perform DoS attacks such as SYN flooding, POD, known as ping of death, UDP application layer flood attacks on a target host. So to do that, we're actually this time going to be a little preemptive, and we are going to open Wireshark again on our Windows 10 machine. So now that we have that running, we can focus on actually attacking the machine. So to do that, we're going to navigate back to Parrot. Now we're already in the terminal. We're just going to do a quick little clear. If you are executing this without following the last steps, you'll do your sudo su command and type in your root password. Since we've already done that, we don't have to worry about it so much. Now that we're here, we are going to use the hping command, and we're going to add a couple of flags to it. We're going to say -S. Now -S sets the send flag. And then we're going to put in our target. We're going to say -a, which is going to spoof an IP address. And in our spoofable address, we're going to use the same 10.10.10.19. Then we're going to specify our port, 22, and we're going to use 2 dashes and specify flood. With all that, we should be able to hit enter. Now you'll notice that no replies will be shown. This is a good way that the actual terminal doesn't have to receive any traffic back. Oop. Clicked a little low. So what we'll do is we'll go back to Windows 10, and if you notice, right now we're at 34,000 packets. But what you should also notice is if I come down here, should have left it open from the last lab, but that's fine, and open my task manager, it is crawling. In fact, this hping has actually froze the computer. So very noticeable. hping is much more powerful than the last attack that we performed. In fact, out of all the things that we are going to perform, I would say that hping is the most powerful. Now, all I have to do is go back. Oh, we might have, nope, I can't even, I can't even scroll down. So what we're going to have to do is go back, go to our parrot, and it's actually going to tell us how many packets was sent. And a small number of 14 million packets transmitted with 0 packets received, 100% packet loss. I don't have to tell you, that's a very big number. And if we go down here to Wireshark, we actually still do not have access to this machine. So this has not only damaged it during the attack, but it has some real lingering damage to it. So what I'm going to do, I'm actually going to restart this machine. That's probably the quickest way for us to actually perform the next couple of steps. So I'm going to put you on hold. I'm going to restart the machine, and we will continue on. So welcome back. Like I said, I had to completely restart the machine, which is fine. That's exactly the type of scenario and results that we wanted to get from this type of attack. Now, what I wish I could have shown you was inside of Wireshark, there's actually an I/O graph, and I would love to have shown you the spike in packets and the error rate, but we weren't able to do that, which is fine. So what we're actually going to do now is we're going to send the ping of death to the same machine. So basically same process. I'm going to come in here. I'm going to open up my mat terminal. I'm going to switch user. We're going to wait a little second for the update to pop up so that I can deny it. But the ping of death is pretty old. It's not something to worry about as much in today's instances of Windows. But with that being said, we are attacking a Windows 10 machine, and you will see that it actually does have results. Hopefully this download pops up, but we'll go ahead and start entering the command. We're still going to use hping3, and then we're actually going to use a dash lowercase d. This specifies the data size, and we're going to use 65,500. There we are. 538. Then we're going to use our dash capital S to send the SYN attack. We're going to send it over port 21, and we're going to do dash dash flood in our target machine. So before we actually send this, the ping of death attack, the attacker tries to crash, freeze, or destabilize the target system or service by sending malformed or oversized packets using a simple ping command. Now, what we're doing here is we're sending a packet that has the size of 65,538 bytes to a target web server. The packet size exceeds the size limit prescribed by request for comment 791 IP, which is 65,535 bytes. So we're actually just adding 3 extra bytes, and with that, we're going to be able to cause a little bit of damage. So let's go ahead and start it. And while we start that, I could have had Wireshark running. But automatically, I'm not able to use anything. And this is exactly as we intended with this type of attack. And I'll show you, I'll click around in a few places so you don't think that I'm just pretending. We're actually getting absolutely, oh, we got a little response there. Try to draw some squares. Can't really do much. And now we have the rotating wheel of death, when it comes to Windows at least. So what we'll do is we'll actually end this for a second. And hopefully, there we go. We have full access to our machine again. So this was a little less detrimental than the last attack that we performed. With that being said, I'm actually going to open Wireshark, and I'm going to re-attack the machine with the same command. And again, before we even get the first packet inside of Wireshark, we have completely crippled this machine. So I'm going to let this run for a few moments. Now what I would have liked to shown you is, Task Manager, basically anything that actually shows the amount of traffic that we're running. And it might actually be a little bit more responsive than Wireshark. I don't see why, but since we are trying to show a lab, and you'll see here, we're actually starting to get some of those packets. But if we go to more details, notice that the CPU was extremely high. It's actually falling right now. We will go ahead and we will execute the command one more time. I'm sorry that I keep opening System Monitor. They just put the selection tab extremely close. So immediately the CPU spiked to 70%, 100%, and now the machine will be unusable. Now not only is the CPU at 100%, but we've used 98% of the memory. Now anybody who uses computers quite often or works on computers should know that a spike in the memory is one of the more dangerous things. The CPU being at 100% is one thing, but consuming all of a system's memory can actually just cause the system to shut down. In this case, my sandbox environment shouldn't shut down, but it is completely unusable. So we're going to go back to Parrot, we're going to end that, and we're going to try to click back fairly quickly and see if we can see the fall. And I might have let it run too long because it seems at this moment at least, we are not getting use of this machine back. Now it could come back at any moment, but for now, and it's not helping that I have no patience and I keep clicking. For now, we have completely exhausted the resources. So again, what I'm going to have to do, so that you guys don't get bored with this video, because this will be a fairly long one anyways, is I'm going to pause the video and I will come back when I have a usable machine. Okay, so now we have our sandbox back up, and actually in this case, we're going to be attacking Windows Server 2019. So I've brought up the information about the server on here. Oddly enough, we're actually using less memory on the server version than we are Windows 10. But in the last two things, we did the SYN attack and we've done a ping of death. Now, as I mentioned, the ping of death was actually patched in October of 2020 on a Patch Tuesday rollout. So it might not work on your machine, but if you have an older version of Windows and maybe you have a machine that hasn't been updated in a while, it should work just fine. In fact, it worked better than fine on my environment because it actually took my whole computer down. No, as you'll see, my CPU is already spiked and we aren't even running anything against it. That's just because Windows Server is actually just starting services because I just started the machine. And with a pretty small CPU, it seems, and let's actually change to our, oh, we can't even change to logical processors, which leads me to believe that this is an extremely small CPU. And I mean, I have to imagine it's not a single core, but I mean, that is what it seems. But anyways, we're going to navigate to Parrot. And in this case, we're actually going to perform the UDP application layer attack that we spoke about earlier. Now we're going to do this over port 139, which is commonly associated with NetBIOS. So the first thing that we're going to do is we're going to determine if NetBIOS is open. And to do that, we're just going to use the same command that we used earlier to determine if FTP was available, only we're going to enter in 139 instead of 21. And now when we enter in our machine's address to attack, we're going to use the .19, which is the server that we were actually spoofing the address of earlier. And we can see here the state of port 139 is open. Oh, and the service is NetBIOS. Now that we know that, all we have to do is perform hping -2. 2 specifies the UDP mode, and we'll specify the port as 139. We're going to say --flood. Normally in Linux, if you're using a full name of a command, you're going to do 2 dashes. And we're going to specify our target, in this case, 19. Now, before we run this, I'm going to go ahead and preemptively open up Wireshark. If this machine can even handle running Task Manager and Wireshark at the same time, that remains to be seen. We'll open up our Ethernet adapter, and we'll just move this. It's weird not being able to do the snap to each side of the machine, but we'll just do one of these here and come back to our Parrot. So we're going to hit enter, and at this moment we're flooding the machine with a large number of packets. So you'll notice that immediately we're at 100% utilization. However, it doesn't seem the system has crashed yet. With that being said, if I actually move this here, you'll see just how many packets we've sent in this short amount of time. Right now, it looks as though we're at 2 million now. So let's go ahead and end our attack. Now it's going to say that it sent 5 million packets. However, it sends packets in such a furious order that the machine actually can't receive all of them in transit. Now, what I was going to say is what's shocking is our CPU went down to 2%, and that was actually the lowest that it had ran all this time. Now we are still getting some weird TCP, and we're actually still getting this FE80, which is just our local link address and IPv6. And if you notice that it is actually a multicast listener report message. And so what could be happening is some of these are actually still piling in because we're seeing a lot of retransmit packets. But for right now, I'm going to go ahead and end Wireshark. So with that being said, we could have used a lot of additional ports. We chose to use NetBIOS over 139 to perform the UDP application layer flood attack. Similarly, we could have used an assortment of other application layer protocols. Just to name a few, we have RPC, port 135, we have SSDP, which is commonly associated with plug-and-play devices. We could have used Trivial File Transfer Protocol over port 69, and many others. Basically anything that we can send a UDP packet over, we could exploit. So with that said, that's basically everything we're going to do as far as HPing for the moment. So next, we're actually going to use high orbit ion cannon. Now this is where it gets to be extremely script kiddie zone, just because of the fact we're using a pre-established tool to actually commit these. Now I know you might think, oh well, you know, HPing is a pre-built tool, and you're completely correct. But at least with HPing, you have to know a few flags and arguments, and there's a lot of niche things that you can actually perform inside of an HPing packet. With high and low orbit ion cannon, we're actually just going to get a GUI, and we're going to perform the flood attack through that. Now, high orbit ion cannon is basically a network stress attack. The tool is written in BASIC and is designed to attack up to 256 URLs simultaneously. It sends the HTTP, the POST, and the GET request to a computer using what's known as LULZ, L-U-L-Z, inspired GUI. It offers a high-speed multi-thread HTTP flood. A built-in scripting system allows for the deployment of quote-unquote boosters, which are scripts designed to thwart DDoS countermeasures and increase the denial of service output. So before we do this, all we need to do is we'll go back to our parent machine. We'll go to our applications, pen testing, information gathering, and Wireshark. Now you'll notice that Wireshark on Parrot has a lot of additional outputs here, but we're still going to use our Ethernet. In Linux, you actually, well, in all computing, you start your numbering at 0, but in Linux, if you notice, we have this, what some like to call etho. It is actually just our Ethernet 0. If we had multiple NIC cards, we would have to select which one we actually wanted to use in this scenario. But so now that we're here, let's go ahead and just open up our Ethernet. And packets should start flooding in like normal. Now we've done a lot of Linux harassing the Windows side, so let's actually use Windows to harass our Linux just a little bit. And to do that, we'll actually go to my CEH tool library. We're going to go to denial of service, DDoS attack, in high orbit cannon. Now you'll notice that high orbit and low orbit look a lot alike. So let's go ahead and execute it. Truth is on the side of the oppressed, by the way. To perform a DoS attack, we're going to run this tool from various machines. So basically what we're going to do is we're going to run it from our Windows 10 machine and one of our servers at minimum. So now that we have it up, we're actually going to go to Windows Server 2019, and we're going to perform the same steps. CH tools, denial of service, attack tools, high orbit, execution. We could perform this from, in fact, let's just do it. Let's just perform this from each of our Windows machines. Now I'm going to cheat a little bit. I'm actually going to open up our reference here. I'm going to hit Control-Alt-Delete, and it's going to enter my password for me. This is, again, like I was saying, this is prepared by the CEHI labs, and so they actually give you quite a bit of tools to speed things up, including all of the tools you're seeing in this folder. Not that you couldn't download this from the web very easily, and the FBI is not going to knock on your door for performing this inside of your own network. So now we have high orbit cannon basically loaded on all of our Windows machines. And so all we have to do is select plus and enter in our target. In this case, we're attacking my Linux machine. We're going to put the power to high. And down here where it says leave blank unless you know what you're doing, it's not that serious. Just go ahead and add generic boost. And we'll hit add. Okay, that's fine. I guess it would help if I entered in the correct address. And one more time for the people in the back. I could follow the instructions, and that would probably help as well. Now, for anyone out there performing this lab, there's nothing wrong with mistakes. I've done this lab multiple times, and as you noticed, I made 2 mistakes right off the bat. What we're going to do is we're going to come down here to the actual successful one, and we're going to turn well. One more time, I guess. 10.10.10.13. Actually don't know how we messed that up. Generic booster. And let's turn our threads all the way up. Well, we'll just turn it to 20. Now, after performing that multiple times, we should be experts. Let's go ahead and add it here. And we're going to use the exact same information. We'll turn it up to 20. And we'll navigate to Windows 10. Basically, what we're kind of putting together here is a distributed denial of service attack. And you could think of this as victims' machines that we've actually already taken control of, which would be a botnet. Okay, so now that we have all of that done, all we have to do is fire the lasers. So we will start with our Windows 10 machine because we're already here. Now if you'll notice our status up here in green, it is at ready. As soon as I click this, it will say engaging. We'll go to our 2019 and we'll go to our 2016. Now if you notice the output, right now we're in kilobits, but it should raise up fairly quickly. That being said, we have already looked at hping, and hping is much more powerful. We are getting a large number of packets as far as it being a short amount of time, but with hping we would basically already be in the millions. So we'll let that run for a little while. We will check on our processor, and even with this being a pretty bare minimum 8 GB Linux machine, it's not stressing it out, basically in any sense of the word. We'll leave this running for a second. We'll let it at least do its best attempt, but at the moment, and even though this could be incorrect because the graph is no longer flowing, there we go, it's a little bit more accurate. It is not going to stress this Linux machine out. And with that, we have now proved that Linux is the superior operating system. Now, all that we need to do is go ahead and shut it down. To do that, we basically perform the same step that we did. We click on Fire the Laser. You'll notice it goes back to ready. And we'll do the same thing. Now, even after running for over a minute, we did not send that much traffic, at least in data senses. We'll go back to Parrot, and we'll watch as our operating system winds back down. So there we go. Looks like we've gotten back down to at least a baseline. I say that, and even normal operations basically do more harmful effects than the high orbit cannon. But it is a tool worth looking at. So with that said, let's look at how many packets we received. And about 351,000. Well, very close to 352,000. I guess I should be fair. However, we're going to go ahead and stop Wireshark. If you notice all the red here, we did have a ton of dropped packets. If we go to statistics, we can actually look at our IO graph. And you'll notice there is quite a bit of errors. But ultimately, if we were able to look at this in Windows earlier, when we performed the hping, this graph would have been exponentially larger. So we'll go ahead and close this out. Another thing we could do is we could actually go to our TCP stream graph, and we could look at our throughput. And it looks as though between 19 and 13, actually no packets made their way through, which isn't exactly anything surprising when you look at how many packets were sent and the fact that basically none of them actually were able to be transmitted correctly. Even round trip time, if we established a connection and data was transmitted back and forth, we would be able to see it in our round trip time here. So let's go ahead and close out of that. And let's look at low orbit ion cannon. Now to do that, we'll go ahead and just go back, and we'll open it up. Now, I've always liked the look of low orbit a little bit better. High orbit is kind of just there for memes at this point, and low orbit makes it look like you're actually executing sophisticated software, even though you'd be hard pressed to tell any penetration tester that this is sophisticated. So in this case, I do not have to do the very annoying HTTP. I should just be able to enter in my IP address and then say lock on. So now we've selected our target. We can go to attack options. And we can select UDP. We can also select the port that we'd like to send it over, but we'll just leave that as default. Now as far as threads, we'll also just leave it as default. And the speed, we'll just put in the middle. And why not? So we're going to do the same thing on our other devices. I wish I could copy and paste, but I cannot. So you have to watch me struggle to hopefully enter it in correctly. Method is UDP. Again, we're going to leave our port and threads as default. Then we're going to slide the speed down in the middle. And our server 2016. So now that low orbit ion cannon is configured on all machines, we're just going to switch through, and just like high orbit, I'm going to charge my lasers. And after doing that, we're actually going to be executing the attack. So beforehand, what we'll actually do is we'll go back to Parrot, and we'll restart this Wireshark. So we'll slide this down here, and we'll go ahead and start executing. Well, help if I locked on. Now that we've started the flood, we can just sit back and see how well it does. As far as packets go, we're sending about the same amount. We are quickly approaching 40,000, and might even be a little bit faster. But you'll notice that in this case, we're sending UDP packets instead of the traditional TCP. As far as flooding a network, it's normally considered a best practice to use TCP. That way you can have an open handshake. UDP, if it's not retrieved or received, your computer really doesn't care. But if you'll notice, our CPU, it did reach 10%. That's a win in my book as far as this type of application. But we'll let it run for just a second, and we'll see if it stresses it out anymore. Okay, that should be good. We've sent over 150, now 160,000 packets. And so now the next step is to just cancel it all. Now, if you notice, we're not using that much CPU. We're attacking from 3 different machines. Just think if we used HPing on 3 different machines and attacked a target. And in fact, that is something that I could show you. But due to the fact that I don't have multiple Linux machines and I don't want to go through all the steps of actually installing a worthwhile tool on Windows, you're just going to have to use your imagination. And it definitely would shut this Linux machine down. So, as far as actually performing the DoS attacks, that's about as far as we're going to go. But what we are going to do is we're going to talk about detecting and actually protecting against DoS and DDoS attacks. But I think we're actually going to do that in another video. So I appreciate you staying with me for this long. I'm going to record the next video basically right now. So if you are interested in this, go ahead and watch the next one. And as always, be safe. Make sure if you're performing any of this, you're performing it in a very enclosed environment. And just don't do anything stupid. Don't attack any type of public IP addresses. Don't attack your friend because you think it's funny. This is all for research and ethical use. If any of this looked like something you're interested in, again, I highly recommend you go and you look at the CEH iLabs. All of the tools and basically the information that I'm bringing to you was brought to me through the iLabs. Now it's I think $200 or something, so it might be out of the range as far as if you're just somebody who's interested or a hobbyist. But if you really want to either take the exam or if you're super interested in this and you want to take it a step further as far as your training, I highly recommend you use it. As always, be safe, and I hope you enjoyed the video. See you in the next one.